Hey, this is Gary and welcome back to my channel. And this video we're going to dive into collisions. And so to kind of make that work, what we're going to start with is updating our base screen. And so I've added two new abstract methods, one for adding the actors and one for adding the decor. And so those can potentially be stored separately depending on the type of screen that we're using in our game. Now the next piece that I've added is a bounding box, and here we have the bounding box will have the X, the Y location, the width, and the height. So when you create a bounding box, it takes the X, Y location, the width, and the height. And the contains checks against another bounding box, and so we check the X and we check the Y, and I'll get in that in just a moment. Then when you set the location, it'll set the X and Y, and then you can set the size, the width, and the height. So to illustrate that, here is a box, and so the other sprite could be another box. So we're checking to see if this guy's X is greater than this X and less than this X location. Then we can move this over here, so then that X doesn't meet. So then it checks to say, hey, is this X in between this X, the other's X, and the other's X plus the width? And then the height works the same way. So it checks to see, hey, is his Y in between my Y and my Y plus my height? Or does my Y location in between its Y location and the other's Y location plus its height? And so here is the logic for checking the X. So my X is less than or equal to the other's X, which is less than or equal to my X plus my width. Or the other's X is less than or equal to my X, which is less than or equal to the other's X plus the other's width. And then it has the same check for the Y location for the height. So the Y, the other's Y, and the Y plus the height. And then it does the other Y. So here in Sprite, I've added bounding box, called it bounds. And the constructor with the width and the height, we create a new bounding box. Set the X and Y location to 0, the width, and our height. And then I'm going to go down here to where we set the height. It sets the height, sets it in the bounding box. Set the location, sets those locations X and Y. Set the size, so that also sets the size in the bounding box. Setting the width, that sets the width. The X location, we call that set location, so it updates the X. And the Y updates the Y. And another thing that is added is the contains method. And so this is used for collision detection. And so it checks to make sure that they're not the same object. And then it does a bounds.contains the other's bounds. And another method I have is called the handle collision, which will take the other sprite and perform some type of collision results, and when that collision happens. And so this does nothing by default. And another method that I added is a Boolean method that does impact. And so what this is used for is to determine if this sprite can impact other sprites. And if it cannot impact other sprites, then it returns false. And if it can, it will return true. Here in the decor class, this class is, like I said, it's a class that does not move. And so essentially stays in one place. So he does not impact other sprites. So this returns false. Now other sprites can impact to this sprite, but that would be handled on the other sprite side. So here in the actor class, we have the does impact, it returns true. since this actor can move about the screen, he will impact or have collisions to other sprites, so he returns true. And I'll show you the kind of the importance of that method shortly. And then here we have the handle collision method, and so it will take the other sprite and it does a check to see if it contains the other sprite, and then it will do a set location, X and Y movement. So what it does is he basically moves him back from whichever direction he was moving. So if he was moving to the left and he collided with another sprite, it moves it back to where before he collided to the other sprite. Okay, now to show this collision more in action, I have created a SimpleScreen that extends our base screen. And so what this guy does is he stores the sprites in an array list. And so when it does the render child, it will go through the for loop of all the sprites. It will call the update method, and it checks if that sprite does an impact. And if it does, it will do the detect collision, passing in that sprite. And then once that's done, it will draw that sprite to the screen. Now I've overridden the add actor method and the add decor method. That just adds them to the sprite list, and that just adds it to the sprite. So it's a simple add to our list. The detect collision will then go to take our sprite, get all the sprites in our list, and calls the handle collision method. And so that passes to our sprite, and we saw that one. It checks to see if the other contains it or not, and if it does, it will then call the handle collision within the actor or the decor. So let's go and give us an example of that. So we'll go back to our tutorial. We're going to add a new class, and we'll just call this simple test, right? And that's going to extend our SimpleScreen. So that just implements the show method, and that's the only method that we have to implement. So going back to our previous examples where we had like the sound screen, we had the show method where we created all our sprites, and then we had to update the render method to make all of that work. And you can see I had to update this to add the actor and add decor, which this guy doesn't do anything. Okay, so back to our simple test here. We'll add our simple test here. So let's start by, we'll set our background color, set that to white, and we'll get our texture, and we'll use our demo character again, create a motion, do our four-way motion. And so our four-way motion, we're going to take the texture. He's going to be 64 by 64. Duration, we're going to do a 0.2. And we're going to use 3, and then 2, 0, and 1. So we got our motion. And next we're going to create texture region. Take our texture, we're going to split it. We're going to create a still motion. And we'll create a new static region animation. So take our texture region, we're going to want 3, I want 1. Another static region animation. Texture region, this time we're going to take 2 and 1. Another texture region animation. Our texture region, This guy, we're going to take 0 and 1. And the last direction, take our texture region, and this is going to be 1, 1. And we'll create our actor. And we're going to do a new mouse movement. And it's going to be input, buttons, dot, use the left button. And it's going to be 0.8 is our speed. This will just be the motion, and this will be our motion still. We'll take the actor, set his location, we'll just put him at 100, 100, that'll do. We call add our actor. Now we're going to create a decor. This will be our soda machine. It'll be a new static animation. It'll be our Osaka soda. And we'll set the soda's location. Put him at 150, 200. And we add our decor. Obviously for the simple screen, it doesn't matter if we call add decor, add soda, since it does the same thing. We'll go to our game. And then we'll run it. So there's our character, there's the soda machine. You see it, she still moves around like before. And we try to move, and you can see it blocks. And so we've hit our collision. Now you notice that the width of the character is actually smaller than the actual bounding box. So we're going to set that background, stop setting it to white, and then we're going to use the demo character JPG. Get that running. There you can see the bounding box, so you can see that the sprite's width is actually wider than what the actual character is, except for maybe like moving up and down. It's a little bit closer towards the edge, but moving back and forth, there's definitely a space there. So you can see that collides with that sprite. And if you try to move, so he can't move diagonally because he's hitting up against the soda machine. So we're going to fix that. So we'll go back into the bounding box where I've made some updates. And what I've done is I've added the X inset and the Y inset to this so that we can have an offset. And then I've added an interface called bounds. And this is for programmers to set the X inset and the Y inset and the height and the width. Now, some notes on setting the inset, and that, you know, it does affect the kind of where the width or the height will end. So if you just change your inset by like 5 pixels, your width is now going to be 5 pixels out the other side. So that's kind of a word of caution that you'll need to also adjust your height and your width. So to use that in the bounding box, we have our new methods to set the X inset and the Y inset. And I have 2 internal methods to set the X edge and the Y edge, and that just returns the X plus the inset, or the Y plus the inset. And so our check X and our check Y are now calling that get edge to determine, you know, if you're within the bounds. So that also caused us to need to update our actor and our sprite. So in the sprite, we have a new method to get the bounds, and so that returns the bounding box, which implements the bounds. And that allows the programmer to be able to access those bounds and make adjustments to that. So let's go back into our simple test, and we'll now set those inset. So we'll do our actor, we'll do our gap bounds, and then we're going to set our X inset, and we'll just make this 10 because it'll make it more noticeable. And then we'll set our Y inset, we'll set that to 10 as well, and then we need to adjust our height and our width. So we'll set our width, so it's 64 to begin with, we move in 10, leaving 54, and we'll set 44 so we have 10 pixels on each side. And then we'll do the same for our height, get our bounds, set our height, also set that to 44. Now before I demonstrate this, what I want to do is take a moment and add some sound to my sprite. Now, I know when you're making games, it's kind of easy to kind of ignore sounds. It's usually a good idea to kind of get used to hearing sounds in your game, even if they're not like the final sounds. So I've created some footstep sounds using that chiptone program I demonstrated in the last video. So we get this guy, and a wave, and I've got 4 sounds, 2, 3, and 4. So I've got a new package for sounds, and I've created a random sound. So this implements the LibGdx sound interface, and it overrides all the existing methods in the sound interface. And this random sound contains a list of sounds, and it contains the current sound. And so when you create it, you pass in a sound, and then you can add sounds. And so if you dispose, it will dispose of all of those sounds. And when you call the loop or the play methods, which basically create a whole new sound, it'll do call this get next sound, which does a random based off of the size of the array list, the number of sounds you have, and sets that to your current sound. And then it calls that corresponding method on that sound. So then if you wanted to pause, it would just do it on that current sound. And if you wanted to resume on that current sound, if you do setting looping, pan, pitch, volumes, it's all on that current sound. Everything is on that current sound. So we'll go back into our simple test here, and then we'll use our random sound. S1, we'll add a sound, S2, we'll add 3 and 4. Now another thing that I've also updated in the actor class, I've created a method to get the move motions, that move motion array, and the still motion array, so that you can get access to those objects, and you can use that. For example, do our actor, get our move motion. We know that we have a single move motion, and then we can set the sound inside of that, our random sound. All right, now we'll see our character with sound. Okay, here's our character, and you'll see we'll have sound. So it's kind of cheesy sound, but that's them walking in now. See, she moves in 10 pixels, and up here 10 pixels, and over here 10 pixels, and then this bottom 10 pixels. Now we're going to make additional updates to the collision detection. So here in the actor, where we do handle collision, so now I've updated it so that it goes into movement to handle the collision. So depending on the movement, it could actually keep moving in a different direction than where it collided, like sliding against the wall. And so to do that, I've updated the movement class to handle the movements. It'll take that sprite update, and it'll take the bounding blocks of the other. So in the sprite update, I added a contains method to verify that if this sprite update contains the bounding box of another. So in the 2-key movement, the handle collision, now he is just moving side to side, and he either moves horizontal or vertical. So he will just kind of go back to its previous position. So in the 4-key movement, it's going to check to determine if it was colliding either horizontally or vertically. And so first it does is it reverts the X update and see if it still collides. And if it still collides, that means it had a collision on the vertical, the up and down, on the y-axis. So then it redoes the X update and then reverts the Y update. So if it didn't contain, when you reverted the X update, then it collided on the X axis, and we just leave that reverted. And the mouse movement, it's the exact same code that was in the 4-key movement. Now the reason that the 4-key movement also has this check if it's colliding on the X and the Y, because you could either have multiple keys or just single keys and update your movement. So if they're just doing a single key update, this will work as well. And if they're doing multiple key updates, this will handle that as well. So back in our simple test, we're going to add more obstacles. So we're going to create a soda on the right. And I'm just going to copy this. And then we'll set our soda right. Set its location. We're going to put them at 350, 200. And then we'll add our decor. Soda right. I'm going to copy that for efficiency. And then we'll do a soda up. And then we'll do a soda to the left. And for the soda up, we're going to set him to 250 and Y at 350. And for the soda at the left, we'll put him at 250 and 50. And then what we're going to do with our character, we're going to stick him in the middle at 250, 250. So we're going to change the actor, and what we're going to do is we're going to use the 2-key movement. We'll do the inputs, dot keys, and we'll do left, or excuse me, we'll do right first. Input, dot keys, and then we'll do left. Let's do our update, and we're doing horizontal. And that is motion, as motion still. Let's demonstrate that. We'll run it. So here's our sprite, he's in the middle. If we go to the right, it collides there, and you notice that he stands still if I let go of the key. Go back to our simple test, and we'll update it to use the 4 keys. So that's input, dot keys, dot up, input, dot keys, dot down, input, dot keys, dot right, input, dot keys, dot left, and we'll set the multi-key to false at the moment. We'll do our motion and our motion still. So here he is in the middle, moving to the right, moving to the left, moving down. You see it stops there, and then moving up. And then we'll come back to our 4 movement key and set it to multi-key. We'll show the character moving at angles. And you see these slides across. And so if you now, one thing I did do, and forgot to mention this, and on the update method, that when it's moving, it will, the still motion, it will take the current still motion and set the direction. And so that way when it goes to the still movement, it'll still be in the same direction. So the motions were updated to now contain the set direction method down here. And so I've updated all these. The single motion, the set direction doesn't do anything because it's just a single motion, just a single animation. And then the others are just setting the direction. And so what it does is it sets the direction based off a directional index. And the 4 and the 8 keys do essentially the same thing. So I won't go into those. Now we'll demonstrate with the mouse movement, and which you still using the left mouse button. And you see it slides. Now the mouse movement, they'll stop moving once it reaches one of its goals. So if my goal is down here, right, so it'll go down a little bit, and it'll slide until she stops. So it's as closest to the goal that she can get. Alright, that's going to do it for this video. And so in the next video, probably get into components and how we'll put those into our framework. Or I might do a demo and kind of make a little simple game using the framework. Until then, be sure to click like if you like the video and subscribe if you're interested in seeing more. And until next time.